Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
A large number of people are fond of creating electromodels, where one of the main elements is an electric motor. At the same time, the assembly and operation of such devices often causes disputes about which motors are better to use. After all, the choice is offered collector and collectorless motors, each of which has its fans and opponents. To try to determine the best option, you need to study the features, the principle of operation, their strengths and weaknesses. This will largely help to make the final decision. Electric motors are part of various automotive equipment, including windshield washers, window lifters, cooling and heating fans, wipers, and so on. But they are also widely used in other areas and industries. Collector-type motor. Under the concept of collector motors fall various electric machines, where the current switch and rotor sensor are essentially one device. With its help, a qualitative connection of circuits in the fixed compartment of the motor with the working rotor is provided. The design includes powerful brushes and the collector itself. Interestingly, the collector type of motor has the advantage of simplicity of care and operation, easy to repair, and long service life. But there is also a disadvantage, which manifests itself in low weight with high efficiency. Initially, this may seem like an advantage. Fast speed together with low weight force to use additionally a good gearbox, otherwise it will not be possible to operate the motor normally. If the machines are adjusted to lower speeds, the efficiency will immediately drop. This, in turn, will have a negative effect on the cooling efficiency. Many people are interested in what a collector motor means. In fact, it is an alternating current machine that can easily convert direct current into mechanical useful energy. At least one winding is connected to the main collector. Depending on the configuration and components included in the motor, collector motors, CM, can be used in toys, radio-controlled models, and in automobiles, acting as a component of the cooling system, ventilation, windshield wipers, windshield washer pumps, and so on. Leading manufacturers have managed to create universal motors of collector type, which are able to operate on all types of current, that is, AC and DC. They have found wide application in the creation of electric tools, household appliances, railway transportation. Their advantage is their low weight and compact size at a fairly adequate price. Regardless of what polarity the motor has, this electric motor will always rotate only in one direction, that is, in one unchanging direction. This is due to the sequential connection of the rotor and stator windings, which provokes a simultaneous change of poles. The torque is therefore always directed in the same direction. The basic constituent components of the FC are a bipolar stator having permanent magnets as its base. Curved magnets of appropriate shape are used in the design, a three-pole rotor. Specific bearings with a sliding effect are also used here, copper plates. They are used as brushes for the collector-type motor. The set is really minimal, because it is found mainly in the most budget and simple versions of collector electric motors. Among them are the motors of children's toys, which do not need increased power. If you want to get a higher quality CD, then it is added to its composition, multi-pole rotors with rolling bearings, graphite brushes. A four-pole stator based on permanent magnets. In order to achieve high efficiency, several major components have been included in the KD, namely, collector. In fact, the basic element of the motor, which comes into contact with the working brushes. As a result, these two components begin to distribute the electric current to the coils of the anchor winding, stator. It acts as the stationary component of the motor, anchor, an indispensable element of collector motors. Inside it, the electromotive force is induced and current flows. It is important to add that the anchor can be the rotor and stator, inductor, a special excitation system that is part of the collector-type electric motor. Serves to create magnetic flux in order to create torque in time. An excitation winding or permanent machines are necessarily present on the inductor, brushes. Brushes are part of the circuit through which the electrical energy follows from the supplier to the armature. Brushes are made of high-strength graphite. Depending on the particular FC, the motor is equipped with one pair of brushes or more. Read also, What features do variable compression ratio engines have? Regardless of the layout and the constituent elements based on certain materials, the principle of operation of all collector motor types remains the same. Operating principle: it will not be difficult for you to imagine two magnets that have different pluses. Try to put them to each other with the same pole and see what happens. You won't be able to connect them, no matter how hard you try. But when you put the magnets together with different poles, you get a high-strength connection. This effect is the basis for the operation and construction of collector motors. You have learned about the design of the FC. Now, in the process of operation, we'll certainly want to know how you can independently check the collector motor. To do this, it is necessary to understand the principle of its operation. An electric motor of this type functions in the following way. The electric current enters the armature windings. Depending on how many windings are used on the motor, the current flows to each winding in turn, thus creating an electromagnetic field, the south pole on one side and the north pole on the other. The magnetic field appearing in the windings interacts with the poles of the motor. Stator magnets. This allows the armature to be set in motion, i.e., made to rotate. The current, passing through the collector and brushes, comes to the next winding. This happens sequentially, depending on the number of armature windings. Passing from winding to winding, the motor shaft and the armature begin to rotate. The rotation will continue as long as a voltage source is available. The standard collector-type motors are provided with a 3-pole armature. That is, it has 3 windings. This allows the motor not to stick in one of the positions. Advantages and disadvantages: there is no denying the fact that collector motors or collector electric motors are actively used in various fields and industries, including they are often used in automotive production. But for objectivity, it should be added that the CD is not always and everywhere used, because in specific situations a more effective and rational solution will be a collectorless electric motor. Extensive experience in the use of CD allows you to highlight a number of strong and weak qualities of the operation of this type of electric motor. The following points can be attributed to the main advantages: a relatively small indicator of inrush current parameters. This is noticeably manifested in situations where collector motors are installed in various household appliances. Such electric motors can be connected directly to the energy carrier, that is, to the network. This eliminates the need for the use of various kinds of additional and auxiliary devices. High rates of speed, independence from mains frequency parameters. If there is a control scheme, the device becomes simpler. But do not jump to conclusions. First, you need to look at the available minuses of the collector motor. Namely, the overall efficiency is reduced. This is due to the presence of inductance as well as the losses required to remagnetize the stator. Maximum torque values are far from perfect, relatively low level of reliability, relatively short service life. Specialists highlight one key disadvantage that characterizes the collector types of electric motors. No one disputes that it is very convenient to adjust the revolutions in collectors. But if they are high, the brushes immediately show themselves. And not in the best way. The brushes are always in a state of tight adhesion to the collector of the electric motor. At high operating speeds, they start to wear out quickly. Over time, clogging occurs, resulting in sparks. Read also, common rail. What it is: the principle of functioning gradual wear of the motor brushes and the entire collector brush. Assembly contributes to a decrease in the overall performance of the CD. That is, the collector brush assembly can be considered the main disadvantage of the design. For this reason, manufacturers are increasingly abandoning collector brushes and opting for brushless analogs instead. The main competitor of the collector type of electric motor is the collectorless analog. It has a different principle of operation from the CD and is also characterized by its strengths and weaknesses. Collectorless motor. Now we can talk about what the collector motor actually differs from the collectorless analog under consideration. The obvious difference is seen when studying the principle of operation of the collectorless motor, CCD. Although the collectorless and collector motor are often compared to each other, perceiving them as competitors, in fact they are two different motors. Therefore, the differences between them are necessarily present. In fact, the BCD works the other way around. The design does not include brushes and the collector itself, which becomes obvious from the name itself. If we talk about magnets, Then in the case of the collectorless, they are placed necessarily around the shaft. In this case, the magnets perform the role or functions of the rotor. Windings with several magnetic poles are placed around the installed rotor. A sensor is present on the rotor. It is also a sensor. Its task is to monitor the position of the rotor and transfer the received information to the processor. This processor works in parallel with the speed controller, which is responsible for the rotational speeds. In total, the information is exchanged about 100 times at a minimum in 1 second. Such a device and principle of operation allows you to get a smoother operation of the motor at its maximum output. In the case of collectorless motors, they can be equipped with sensors, as well as operated without them. If there is no sensor, it will reduce the efficiency of the entire motor to a certain but insignificant extent. Recognizing an OBD with and without a sensor is quite simple. If a normal motor has 3 power wires, then models with a sensor additionally have a loop consisting of thin wires. It goes from the motor itself to the speed controller. Advantages and disadvantages. The main and undeniable advantage of brushless electric motors is the almost complete absence of parts that can wear out. It is impossible to talk about their complete absence, since the rotor shaft is mounted on bearings. It is these that can wear out over time, although even the bearings have a huge resource. Plus, it is always possible to replace the bearing quickly and without much difficulty in case of wear. These design features have resulted in the advantages of reliability, high efficiency, and long service life. The presence of a rotor position sensor improves rotor performance and accuracy during operation. Remember the disadvantage of the collector counterparts, where brushes spark and wear out quickly, in parallel causing interference in the operation of the unit, mechanism, or machine in which the sensor is installed. In the case of collectorless or brushless motors, this problem has been eliminated. No sparks are observed here. Collectorless motors do not rub, do not overheat, which also rightly refers to the weighty advantages of the mechanism. Additional maintenance in the process of even very active operation is not required here. If we talk about the disadvantages, then from the essential and still conditional, only one minus can be distinguished. This is a higher cost. The minus is conditional due to the fact that the price excludes the need to replace the springs, armature, collector, or brushes. Therefore, the cost fully and completely justifies itself. Then you can already make your own subjective conclusions based on the above information. In conclusion, understanding the differences between collector motors and collectorless motors is essential for making informed decisions in various applications. Collector motors, with their robust design and high starting torque, are ideal for tasks requiring precise control and high power. However, they come with drawbacks such as maintenance needs and potential wear over time. On the other hand, collectorless motors offer advantages like reduced maintenance, longer lifespan, and quieter operation, making them suitable for modern applications where efficiency and reliability are paramount. Ultimately, the choice between these two types of motors will depend on the specific requirements of your project and the trade-offs you are willing to make. Thank you for watching, and we hope this video has clarified the key differences and considerations for you.